I will be explaining you Jacobson lemma in this video. Okay, so here you can see the statement of the lemma. This is the named lemma. So as you all know that this is a very important lemma, or I can say a very expected lemma in our semester examinations. Okay, so here I will read the statement. If f is of characteristic 0, what they are saying? They are talking about f. We all know what is f. F means field, right? So they are saying that this f is of characteristic 0. It means the characteristic of f is 0. That is what the meaning. Okay. And if s and t in AF of V. Okay, that is you are taking two elements. They are S and T from where? From AF of V. Okay, or such that ST minus TS commutates with S. They are saying this. Okay, ST, this S and T, ST minus TS commutates with S. It means they are saying this. Okay, ST minus TS commutates with S means what? ST minus TS into S equal to S into ST minus TS. This is what the meaning. Okay. Then if these conditions are there, then we have to prove ST minus TS is nilpotent. Okay. That is what we are going to prove. We have to memorize this statement also. As I tell you every time, we should not try to memorize it without understanding what is there in the statement. Just what we have to do is, we have to keep something, okay, only something that is important in the statement in your mind. Okay, when it comes to this statement, the things that you have to fix in your mind is, first one is, you have to take a field. You have to talk about the field. Okay. So what you have to keep in your mind is, there is a field F, and I told you the field is having a characteristic, that is characteristic 0. F is of characteristic 0. Okay, that's the first point. And then what they will say is, they will take two elements S and T from where? AF of V, and such that, and they will say TS minus ST minus TS commutates with S. If these conditions are there, then we have to prove ST minus TS, the same ST minus TS is nilpotent. That is what we have to prove. So without wasting time further, let's start. Okay. So here you can see the statement, and this is the proof. This is very simple. Okay, I will explain you. First you have to write what is given in the statement. Just copy down from the statement. Right? ST minus TS commutates with S. It means I told you, from this sentence they are conveying this. Okay, from this line they are conveying this. So that is what I am writing. I am writing this from the statement, and implies you have to write this. ST minus TS into S is equal to S into ST minus TS. Now this is what the commutative property, right? What is the commutative property? TS equal to ST. Here ST minus TS commutates with S. That is why here you are writing like this. You are writing with S here. Okay. I hope you can understand. And then what you are doing is, you are going to, what you have to prove, ST minus TS is nilpotent, right? So that is what you are writing. To prove ST minus TS is nilpotent. To prove ST minus TS is nilpotent, by the definition of nilpotent, you are going to prove this. Okay, that is to prove. You are writing this for some K. How you are writing this is, you are writing this from the definition of nilpotent. Can you understand that? So that is to prove ST minus TS power K equal to 0 for some K. Now consider the left hand side. Okay, at the end of the proof, you will bring 0 in the right hand side. That is what we have to prove, right? So consider the left hand side, that is equal to, this can be written like this also. The value is not going to change, so this can be written like this. Now what you are doing is, you are multiplying, that is this whole term into this, and put this minus, and then again this whole term into this. Okay, that kind of multiplication you are doing here, so that you will get this line. And in the next line, what you are doing is, you are making a small bit of adjustment. That is, write this st minus ts power k minus 1 into, put this s and put this bracket and then t. That is, the value is not going to change. Okay, so you are making a small bit of what? Adjustment. Minus, again st minus ts power k minus 1 into, put this t and put this bracket and put this s. Okay, now what you are doing is, write this term as it is, but here you are making a little bit of adjustment. That is, you are bringing this s to this side, s into this value into t. Okay, you are doing this only to this term. Why you are doing that? Because here you have wrote, what you have wrote, sorry, yes, wait a minute, I will tell you. Okay, I found it finally. I will tell you how you are writing this. Look at this. Okay, this is in this format. Okay, st minus ts into s. This is also st minus ts, but you have power here, but the power is not going to disturb you. Okay, look at st minus ts power k into s. This and this are in same format. So if it is like this, then you can write like this, right? S into this term. So that is what you are writing. Here you are having this into s. So you are writing s into this term. How you are writing? Using this. Okay? Okay. After writing this, you will get this. Now what you are doing is equal to s into, instead of this, you are putting b, minus, instead of this, you are putting b. These two are same, right? So you are putting, for this, you are substituting b here. Okay, so b into s. So where b equal to this value. And now keep that. After that, you are taking trace. Okay, this is the value of st minus ts power k is equal to this value, and now you are taking trace for this value. So trace of this equal to trace of st minus ts power k can be written like this, because just above you have found it, right? St minus ts the whole power k is equal to this value, so that is what you are substituting. Now you are, if trace of this minus this means, you can write like this. Okay, you have a property for trace, so using that property you are splitting like this, and then you are writing trace sb minus trace bs can be written like sb. Okay, you are doing that adjustment here, and after that, you know that trace sb minus trace sb is what? 0, right? So finally you brought our answer, right? Finally, we have proved st minus ts is nilpotent. You may ask me, here trace of this value, you got equal to 0, then how you can say this equal to 0 is proved? The question is a very, very great question. By a lemma you are saying that, okay? You have a lemma. Let us turn page 6.8.3 lemma. So you are saying that from this lemma, okay? Lemma 6.8.3, by using this lemma, you are saying if we get a trace of this value is equal to say 0, you can say what? st minus ts is nilpotent. Okay, by the lemma you are saying. Okay, Thank you.